Welcome back. We're going to finish up this problem 30 and then move to the back. Okay, so I wrote out a few things since I just talked to you a minute ago. I'm noticing all three triangles must have to be similar, and I drew them all separately. The big triangle, small, medium, big. This medium triangle here, small, medium, big. And this baby one, small, medium, big. Now it looks like they've set up these ratios AD, so that's this whole side, the big side of mom, AD, with a ratio BD, okay? So that's the small side of mom. So they set up a ratio, the big side of mom over the small side of mom, and then is it equal to BD, so they gave the same length here. But now I think they're talking about BD would be the big side of this baby. BD is the big side of the baby, big side of baby, and CD, small side of the baby. So it should make sense that the big side of mom or the small side of mom should be the same ratio as the big side of baby over the small side of baby. Now this second statement, AD, once again, that's the big side of mom, over AB, that's this medium side of the mom, should be equal to the ratio AB. So AB is the medium side of mom, but it's also this big side of the teenager. I call this one the teen. Okay, because I've got a mommy, a baby, and then one right in between there. So the big side of the teen over AC, that's this medium size of the teen. So we have ratios set up here, and those ratios should be equal to each other. The ratios are equal because they make a ratio, the same ratio. So how can we then complete a statement that would add these up, square it? So that would say the small side of mom squared plus the medium side of mom squared has to equal the hypotenuse squared. I think we already know that because of Pythagorean theorem. But can we piece this together in order to prove this? And I think you can, but part of what you have to recognize is that this side, AC, plus that side, because how did we get from a bunch of fractions to an addition statement in order to prove that Pythagorean theorem would work? So I think you'd need to take segment AC and add it to segment CD in order to get the whole segment. And that's exactly what they did. So I'm definitely going to pick D there. Kind of a weird, tricky question, but we're going to move on. Okay, so the next question on the back said, based on these dimensions and they're equally spaced, can we solve for X? So I'm going to focus my eyes on this triangle. That's where X is. And I'm going to redraw that. So we know this is X. And that's 16 plus 16 plus 16. So that's 16 times 3 is 48. Or you can do 16 plus 16 plus 16. Okay, so one triangle is that. Notice that's a right angle and that's the same angle. Also, they told us this 40 inches. So now my eyes are focusing in on this whole triangle, right? All right, that one and that one. So this is 40 inches, and this is 16 times 4, right? And that'd be 64. Now, we know that because of the angle similarity theorem that these should set up to make the same ratio. So I'm going to use the smaller one first, list it least to greatest. So X and 48. So this is smaller, and that one's medium, next bigger. This one's smaller, that one's bigger, so set that up, 40, 64. And we're just going to cross multiply to solve for X. So when I do that, I get 30, and I see, aha, that's one of my choices. Next question. Two sides of this triangle, AEB, so it says two of the sides extend to create similar triangle ADC. So they went out and said they're similar. That means their sides have to make the same ratio. If y represents the length of AD, then what's the value of y? So if we think of this, let's say this was the number 10. We don't know it is, but let's say it is 10. Then we would know that's 4. So in our mind, we'll take whatever y is and subtract the number 6. Just like we would in our brain. If that was 10, we'd now know what that is because it's just whatever 10 is minus 6 would have been 4. So this length should be y minus 6. Okay, now we can set up ratios. So this looks like the smaller side. So I'm going to use this area here. So the smaller side is y minus 6 and the bigger side is 12. And now looking at the mom, so I'm just going to focus my eyes on the whole triangle now. We're told this whole side is y, that one's smaller, and this whole side has to be 20. The whole side of mom is 20. So I listed those least to greatest. Okay, now I'm just going to cross multiply to solve. So I have 12y. 20 times the expression y minus 6. So let's go ahead and distribute to get rid of parentheses. It's 20y, 12y. Okay, let's add 120 to both sides. Subtract 12. That would give us 8y. It's 120. So if I take 120 and I divide by 8, I get 15. Now again, we can double check our answer. So if this is 15, then that would end up being 9. And you can plug these back in to make sure that is the number 9 over 12 equal to medium, bigger, equal to 15 over 20. And the answer would be yes. If you multiplied 12 times 15 and 9 times 20, you'd get the same thing. Okay, let's keep going. I want to do this little one here. So these are designating that that's in the middle, and this is designating that that's in the middle, and so that means that we know that DE is the mid-segment. Now that means that we actually know the ratio that the mom and baby make because the baby is half as big as the mom. So we know that if we took 2 times DE, we should get the bottom of mom. Doubling this gets that. We've done quite a few problems like that. So if we double DE, we're going to get AC. Now let's see what the problem states. It tells us specifically those were the midpoints. So it's basically telling us it's the mid-segment. And it's saying they're similar, which we know because of side, angle, side. They both have sides and they share this angle B. If DE is 12, so if this is 12, we know the mom is 24. And now it says if DE is 12, yep, then we know AC has to be 24. And let's say they told us BE is 7. Well, again, we know that's 7 because 2 marks, 2 marks. So we technically know that the side of mom is 14, right? And we could probably figure out what that is. So it says, what is the length of AC? Oh, that's weird. It doesn't really matter. The minute we knew DE was 12, we knew AC was 24. So everything else was kind of a distractor. All right, last question. The Pythagorean theorem can be proved using these 3 similar right triangles. Cool. That's what we did back here. And we actually knew how they did it. They definitely needed this to finish out these theories. And then they just used algebra. So what if Pythagoras had never lived? Would we be able to come up with his theorem without his invention? And that's what this is. Okay, so let's walk through these steps. It's saying that all 3 triangles are similar. That's the similar triangle, and we figured that out. And the reason is, here they gave it to us. But we also know it by angle-angle similarity. Now they set up these ratios, same thing. Big side of mom, C, over small side of mom. Big side of baby over small side of baby. Kind of the same ratios we set up before. This one talks about mommy and then the teenager. Okay, So now they want us to multiply. So let's figure out which of these, put the following steps in order. So where did they multiply? Okay, so here looks like they've multiplied. They haven't added yet. So it looks like what they've done is cross multiplied. Notice if we cross multiply, we're going to get b times b, which would be b squared, and c times d, right? That's exactly what they got there. And if we cross multiplied here, we'd get a times a and c times f. That's what they did there. So that needs to be step 3. Now it says they added stuff. Addition property of equality. So that's weird. Addition property of equality must mean they added the same thing to both sides. So let's see who added stuff to both sides. Now this is our finish line. We want to prove Pythagorean theorem. So this one we know has to be the last step, is we end up getting Pythagorean theorem because it says prove Pythagorean theorem. How can Pythagorean theorem be proven? Okay, so definitely we need this one to be last. Now let's see. This definitely looks like they added stuff to both sides. So we had b squared and we had a squared, and it looks like they added them together. They took this part, and it looks like they added them together. So I'm definitely liking this one for the second step. And then it says segment addition postulate. So that's this idea from the last problem. Segment D plus segment F should equal segment C. That's just segment addition. This segment plus this segment should equal the whole thing. So that's the step we need, step 5. Thanks for joining us.